Hello everyone, welcome back again in the class of Operations Research in CPM PERT. So in previous lesson, we have seen how to construct a network. And those who have not attended those class, so I advise them to please go and watch that video first because that is the most basic video we have. And today's class, we will understand what is a CPM and a PERT, and we will know the network calculations that are required in CPM specific. So let us start with something what we have done in previous class, that is an activity. We all now know that activity consumes time. All right. So some of the activities, they consume different times. Some of the activities consume a fixed amount of time. Now it depends on the quality of work or the quality of activity they are doing. So there are different types of activities. In some of the projects, we require more specific time. That means it may be more, it may be less because of the uncertainty that arises. And in some of the activities, more or less, the time is almost fixed that this much time will be required for an activity. So the time where there is less fluctuation or is almost same, we call it a fixed time activity. And the time where there is some sort of uncertainty and where the time fluctuates, we call it different times, okay, or maybe range of time, what we can say. So here today we will understand CPM and PERT. Let us start one by one. So first let us see what is there in CPM. So CPM is basically an activity oriented. We'll come back to it very quickly. And then it is a deterministic model. Deterministic model means when the activities have fixed time, okay, we only require to calculate the total amount of time that will be needed to complete the project, and nothing else matters much. And as we have discussed just now, that it has a fixed time. That means there is not much variation, not much uncertainty when the activities are taking place. Generally used for repetitive works. Repetitive works means that are done more frequently. All right. Suppose the construction of a house, we know that we generally do construction in summers or winters, and the process of construction is almost repetitive when there is no uncertainty. All right. And whereas when we see PERT, it is an event oriented. Okay, we'll come back to it. What is event oriented? It is a probabilistic model which suggests that it has a range of time. When we say the range of time, that means activities are differentiated in times, or there is uncertainty that is affecting the time of the activity, and that's why it deals with the probabilities. What is the probability of completing it in this days or that particular time? So this is what PERT deals with, and it is generally used where there are non-repetitive work. Suppose we are doing some different type of work which is non-repetitive, which may happen once in a while, just like launching of a satellite. So every time we do that, you need different level of skills, different level of planning. Everything has to be very specific. You need different level of skill level, advices. So all these things makes it a different part when we are doing PERT, and different part when we are doing CPM. And activity oriented means the focus is on the activity. All right. In CPM, we say it activity oriented because the focus is on the activity, the time which activity is consuming. And when we are talking about PERT, it is event oriented. That means it depends, or it focuses on the completion and starting point. All right. So it is less bothered about the time activity consumes because it has a range of time. It does not have a very fixed time, just like CPM. So that's why we focus on events in PERT and we focus on activity in CPM. That is a very common question you find in competitive exams also, that CPM is an activity based and PERT is an event based. Now When we came to know all this, let us now understand what is the objective of CPM. So first we'll deal with CPM. Let us see the objectives of CPM, what we need to do when we do CPM. So it is used to find the total duration to complete the project. So basically it is done to find the completion time of the project, at which time the project will be completed. Now, most of you were thinking that when we say critical path method, it will give us the minimum time in which the project is completed. It is very untrue. CPM always calculate the maximum time a project can take, because after that maximum time there should not be any delay. So we'll come to this when we draw network and solve the critical path calculations. But you need to remember one thing, that critical path method gives us the maximum time, not the minimum. This is the biggest misconception that students do. Now, classification of activities of a project as critical and non-critical. So when we are drawing a network, when we are finding the critical path, the path which we found out are critical path because the activities are critical. We will see in a moment what it is, and the path and the activities which are not involved in that path are called non-critical activity. Now, critical activities has an extreme significance when we are drawing project. That is, we cannot delay the critical activities. If we delay any of the critical activity, the whole project time will be delayed. We will see how. Now, critical activity, as we said, that delay in this will delay the project. Any delay in the critical activities will definitely delay the project. And when we are talking about non-critical activity, a certain amount of delay can be done. All right. So after knowing all this, let us jump on to the calculations we need. So to understand this, let us see one thing. To carry out the necessary computation, we need to find the earliest and latest time. Now, what is this earliest and latest time? Let us see those. Earliest occurrence time of event J is EJ, is represented as EJ. Latest occurrence time of event J is LJ. So when we say occurrence time of event we have discussed in previous class that event is the instance of time. It does not consume time, it is the instance of time. So at particular event, how early an activity can be started, that is the earliest time. How late an activity can be started, that is the latest time. Or in case of finishing event, how early an activity can finished, or how late can an activity can be finished. So this is how earliest and latest times are defined. And Dij is the time of activity, as we already know. So here is the example where there is an activity X, I is the starting event, J is the finishing event, and the earliest time is EI and LI for the starting event I, and EJ and LJ for the finishing event J. So I hope the earliest and latest times are very, very clear to you. Okay. Now let's move ahead and understand the critical path calculation. So critical path calculation is done in two ways. One is we have to go through forward pass first, and in forward pass we generally calculate the earliest times. After that we do a backward pass where we calculate the latest times. Now let us see how we calculate forward pass, backward pass, and let us see with an example. Here is a network, a similar network what we have drawn in the previous class. So this is the network we have already drawn, and this time activities has a fixed time. Can you see? Activity A has 6 days, activity B has 6 days, C has 3 days, D has 5 days. So all the activities have a specific time, and DM is the dummy activity. I hope you remember the concept of dummy activity we discussed. Dummy activity is nothing but no time consumption. It only is used to show the dependency. All right. Now, as we see here, we will start with the forward pass. When we say forward pass, we will calculate the earliest times only. So let us start. When we start forward pass, it is started from the first node, and we will always take the first value as 0. So E1 is equal to 0. Now as we move to the next node 2, we will see how many incoming arrows are there. So in this case, we have only one incoming arrow. Here it is. Okay, so we can write the value of earliest time at event 2 is 6. Here it is. Now let us move to the next node, which is 3, node number 3. So as we move on node 3, we will see how many incoming arrows are here. And here we can see there are more than one. There are 2. Here B is also coming, and a dummy which is showing the dependency of A is also coming. Now whoever has the maximum time, we will select that whenever we are calculating earliest times. So let me write it here. It will be more convenient if you remember. Okay. We will have maximum time, maximum, whenever we are calculating earliest time. So I think this is good. So this is 0, 0 plus 5 is 5. So there is one possibility of 5, and the other one is E2 is already 6. So 6 plus dummy activity, we know that dummy activity has 0 time. So 6 plus 0 is 6. So among 5 and 6, 6 is greater. So the value of E3 is 6. That means earliest time at node 3 is 6. Let us move to node 4, and here also we see 2 incoming arrows. So there are 2 times. Let us see what are those. 6 plus 3 is 9. This is one possibility, and the other one is 6 plus 5. 6 plus 5 is 11. So let us take the maximum value 11. So here we are done with the forward pass. Now let us move to the backward pass, where we use the latest time. Now when we are using the latest time, we will use the opposite technique. That means we will use the minimum value. So I'm writing it here, minimum. And this time, because it is a backward pass, we will start from the final node or the final event. Here E4 is 11. So by default, we will make L4, that is the latest time here, as same as this earliest time 11. Now we will go back to the previous node and see how many arrows are starting from there. So from 4, let us go back here to 3, and we can see that only one outgoing arrow is from here, and this activity consumes 5 days. So simply we will reduce 5 days. So 11 minus 5 is 6. So there is one possibility only. So let me write it 6. So L3 is 6. That is latest time on event 3 is 6. Okay, I hope this is clear now. And let us jump on to the previous event again. So let us come to event number 2. Okay, so there are 2 outgoing arrows, this one and this one. Let us see which one is minimum. So L4 is 11, and this activity consumes 3 days. So 11 minus 3 is 8. That is one possibility. And here L3 is 6. 6 minus dummy. Dummy consumes what time? We have discussed it. Yes, it is 0. So 6 minus 0 is 6. So 8 and 6, whichever is minimum, we are going to take it. So let us take 6. So L2 is 6 here. Now let us get back to L1. Here again, L3 is 6. 6 minus 5 is 1. So L1 can be 1, or it is L2 is 6. 6 minus 6 is 0. So whichever is minimum we will take. So automatically L1 is 0. Now we have found all the earliest and latest values. And after calculating this, we will notice that at some of the nodes, we get the equal value of E and L. In this case, we see that at all the nodes, we got the value E and L as same. That means when we are drawing critical path, we have to cover all the points which has the same value of E and L. And how we are going to do that, let us see. Now when we start from 1, And if I move towards 3, I realize that I can now only move towards 4, which is the final event. I cannot move towards 2 because the arrow is incoming, not outgoing from 3. So I cannot move in this direction. And the other way is I can go to event number 2, and from here I can move to event number 3 and then 4. So this is a proper way how I can cover all the nodes when we are creating a path. So let us do that. Let us do it here this time and start. Okay, can you see it? Let us see that again. Okay, beautifully done. So this is our critical path. Now we have found the critical path. Let us see what are the things we have. So first is the critical path, which is consisting of event 1, 2, 3 and 4. So 1, 2, 3 and 4. So this is our critical path, or we can show it in the form of activity also. So A, D, M and D. This also we can write. And then the critical activities. The activities which are in the critical path are called critical activities. Here activity 1, 2, 2, 3 and 3, 4. So activity 1, 2, 2, 3 and 3, 4. Or we can call it activity A, D, M and D. Activity A, D, M and D. So these are critical activities. That means we cannot delay these activities. If we delay these activities, our project will be delayed. And the non-critical activities are the remaining two, which is 1, 3 and 2, 4. 1, 3 and 2, 4, which eventually is activity B and activity C. Fine. And the project duration. The project completion time is 11 days. This E, earliest time we calculate, itself shows us clearly that the total completion time is 11 days. So this is what we calculate, what we find out in critical path method. Now let us understand something more. Let us observe what we got through CPM, that is critical path method. First is that the critical activities must be stacked one after other to ensure the project is completed within the specified 11 days duration. So as we said that critical activities cannot be delayed, so it must be stacked one after another. If not, then our project time is going to delay. That is one thing we observe. Next thing we observe is that the non-critical activities have time span larger than their respective duration, thus allowing slack in scheduling them with their allotted time interval. So here it is using the word slack. Slack is the additional time they have. They have some additional time, the non-critical activities, and we may delay them within that slack period of time. So that's what it is. And now let us take one more example and understand it very, very clearly. So this is the question, task A, B, C, D up to H and I, and this is the precedence it has shown, and the time of each activity is given. We need to find we need to draw the network and find the minimum time of completion of project in days. Actually it is minimum possible through critical path. Also find the critical path. Fine. First thing is that we need to find the dependency properly, and we need to write or make a precedence table, just we used to do in a previous class where we have drawn the network. So let us quickly make a table, and these are activity A, B, C, D up to HI and the precedence. So let us find the precedence. We'll start from here. A depends on D, A depends on D, or I think it's opposite because the greater than sign is here. So the D depends on A, it is, I guess. Okay, D depends on A, yes it is. So this is D depends on A. Similarly here activity E depends on activity A, E also depends on A, here it is. F depends on B, so F depends on B. Okay, F depends on D also, so here it is B and D. Then G depends on C, G depends on C. H depends on C. Okay, H depends on C. And then we have I depends on F and I depends on G. So I depends on F and G. Now, after completing this precedence, we realize that there is no precedence for activity A, B, and C. That means they are unpreceded activities. Unpreceded activities, if you recall what are unpreceded activities, that activities which can start from the very starting node. Okay, they are called unpreceded activities. Let us move ahead and start drawing the network here. So first we will draw the starting event. Here is the starting event, and we can draw all the unpreceded activity, that is A, B, and C together. Let us start making them. Here it is. Now, activity D and E both depends only on A. And when we see the next precedence, we saw that there is no A in combination of any other precedence. So what we can do is we can terminate A here. That means A activities end, and from here we can start activity D and E. So let us start activity D and activity E. Again, I should remind you that whenever we are drawing activity, we should not immediately conclude the activity. We should let the activity open, and whenever we feel that we need to conclude, then only we should conclude or end the activity. Fine. Let us see ahead. Activity F depends on B and D together, and as we see further, there is no B and D, so I can terminate B and D on a common node. Let us do it here, and from here I can start activity F. Fine. Activity G and C depends, G and H depends on C, and there is no further C, so I can end activity C here, and I can start activity G and activity H. Here it is. Now activity I depends on F and G, and there is no further activities, so I can conclude F and G at a common node, and from here I can start activity E. Now activity I. Now once all the precedence or activities we have drawn, we will see how many activities are open. So we realize that E, I, and H are the activities that are open, so we will conclude it on a common node like this. So our network is ready. Now let us start numbering them. We know, or we have learned in the previous class, that we use the Fulkerson rule to number the events. And let us start from here. So the first event is 1. Now after naming this, we will delete all the outgoing arrows, that is A, B, C are deleted, and from here we realize that there are new initial events with no incoming arrows are created, this and this. So we will name them 2 and 3. Here it is. Now again we will delete the outgoing event from 2 and 3, and let us see what happens. So if we delete outgoing arrows from 2, we realize that this becomes initial event, and this is number 4. And then we delete from 3 and 4, we realize that this becomes initial event, so this is number 5. And finally our final event, number 6. So event has been numbered, network has been drawn. Now is the time to calculate the CPM calculation, that is earliest and latest time. So let us go with forward pass and start with first event E1 equals to 0. Let us move to the second event, only one incoming arrow, so E2 will be 8. Let us come to the third event here, and E3, only one incoming arrow, so E3 will be 8. Let us move to fourth. In fourth we see 2 incoming arrows, so let us see which one is maximum. Remember, when we are doing forward pass, we will take maximum value. When we are doing backward pass, we will take minimum value. So let us take the maximum value here. 8 plus 10 is 18, and this is 0 plus 10 is 10, so we will take the maximum value 18. Let us come to 5. Again we have 2 incoming arrows, so 18 plus 17 here is 35, and 8 plus 18 is 26. So we will take the maximum, and E5 will be 35. Let's come to the final event, and here we have 3 incoming arrows. So let us see. 8 plus 14 is 22. Okay, and then we have this 35 plus 9 is 44, and then we have 8 plus 16 is 24. So definitely the maximum value here is 44. So E4 will be 44, and this will going to be our project completion time. Now let us go to backward pass, and we will start from the final node, and the L6, that is the latest time here, will automatically become 44 here. Let's come back to the previous event, which is event number 5 here. So just one outgoing arrow, so subtract 9. 45 minus 9 is 35. So L5 will be 35. Let us come to 4. Again, only one outgoing arrow, which is activity for 17. So let us subtract 17 in 35. It will be 18. Okay, fine. Let us jump to node number 3. Here we have 2 outgoing arrows. So let us see which one is minimum. This time we will select minimum. So 44 minus 14 is 30, and 35 minus 18. 35 minus 18 is 17. So let us take the minimum value, which is 17. So L3 is 17. Let us come to event number 2. And again, we have 2 outgoing arrows. So let us see one by one. 44 minus 16. 44 minus 16 is, I think, 28. And this is 18. 18 minus 10 is 8. So let us take 8, which is minimum. And let us come to the first event. And we have 3 outgoing arrows. So let us see. 17 minus 8 is 9. 18 minus 10 is 8. And 8 minus 8 is 0. So definitely we're going to take with 0. Now we have all the earliest and latest times, and we will see at which nodes E and L are equal. So we can see at node 1. Okay. Let us see here at node 1. Here it is. At node 2, here it is. At node 3, no. At node 4, yes. At node 5, yes. At node 6, yes. So we have 1, 2, 4, 5, 6. These are the nodes where we can see that the value here of E and L are same. So our network or the critical path will be something like this. Okay, fine. Let us see it again. It will be something like this. Fine. So this is our critical path. Let us see the critical path, which is 1, 2, 4, 5, 6. And in the form of activity, if I'll write, it will be A, D, F, I. Fine. Critical activities are A, D, F, I definitely, or we can say 1, 2, 2, 4, 4, 5, and 5, 6. Here it is. And the non-critical activity, as we can say, 1, 4, 1, 3, 2, 6, 3, 5, and 3, 6 here. And the total completion time of the project is 44, as we can see it here. So I hope you enjoyed the class. I hope you understood all the concepts. And one more thing, if you need to learn operations research in detail, I have created the concept, and it is available on the app. The description of the app is given in the link. So please see it, go through it, and see if it is useful for you or not. So I hope you like it, and if there is any more content that you want to be shared on YouTube, so please comment on us, and we will go through. We will try to provide you everything you need. So thank you for watching. Thank you very much.